Hello everybody and welcome to exercise 1 at the bottom of page 27 in the workbook here. And this is the continuation of the problem that we did at the top of this page. This is asking us to use the formula that we just derived to find the average value of a function to actually find the average temperature in Rapid City between 12 noon and 3 p.m. Okay, so let's remind ourselves of what the pieces of the puzzle were here. Okay, so first of all, our formula for the average value of a function looked like this. That's what we're going to use to do this calculation. And then the actual temperature function was what was given up here. Okay, so that's the f that we're going to use. Okay, so the first thing we need to determine if we want to use this formula is what are the a and the b? Well, a and b are that's the interval over which we want to find the average. Okay, so that's referring to these two clock times. And in our problem, 12 noon was 0 and 3 p.m. was 3. Whoops, that second one is b, not a. Okay, so a is 0 and b is 3. Okay, so using the formula for the average value, we need to take 1 over b minus a, which is 1 over 3 minus 0, integral from 0 to 3, and then we want to integrate the function, and I'm just going to copy down its formula. It looked like 30 sine of pi over 2t plus 10. That's what we actually need to integrate. Okay, now to do this integral, we actually need to do a u substitution for the first term here. I'm not going to write out all the details, but basically what you'd want to do is let u be pi over 2t. That's going to make du pi over 2 dt. And you'd follow through the rest of the steps of the u substitution, and I'm just going to show you what you should end up with. You can check me on that. Okay, so we've got a 1/3 out front, and then the antiderivative for 30 times sine pi over 2t. We're going to integrate sine. That's going to give us a negative cosine, so we're going to get a negative 30. There's going to be a factor of 2 over pi that occurs because of the substitution that we did. And our antiderivative, the rest of it's going to look like cosine of pi over 2t. Okay, that factor 2 over pi that you see has to do with the u substitution. I'm asking you to confirm that on your own, that that's correct. Okay, and then we're ready to integrate 10. What would an antiderivative for 10 be? Well, it's just going to be 10t. Okay, and then we're going to evaluate that between our limits of 0 and 3. Okay, and see what we get. So let's do that. Let's substitute our two limits in, starting with 3, the upper limit. So we're going to get negative 30 times 2 over pi times cosine of 3 pi over 2 plus 10 times 3. All of that's our upper limit. And then if we plug in the lower limit, negative 30 times 2 over pi cosine of pi over 2 times 0 is 0, plus 10 times 0 is 0. Okay, and let's take a look at what we've got here. There are a couple of nice things that happen. First of all, cosine of 3 pi over 2 actually ends up being 0, and that's going to take this entire first term and make it go to 0 for us. So that just disappears. Okay, and then another nice thing, cosine of 0, not equal to 0, but it is equal to 1, which is a reasonably nice number. Okay, and so if we just put this all together and see what's left, we're going to get a 10 times 3, that's going to give us a 30. Okay, and then we've got a minus a negative, that's a plus 60 over pi times 1. We're now looking at this term, and then the plus 0 on the end, we don't even need to write that. Okay, now this would be our final answer, 1/3 times 30 plus 60 over pi, but that would be kind of weird. Somebody asked you what is the average temperature, you probably would not give your answer that way, as 1/3 times 30 plus 60 over pi. People would look at you kind of weird if you did that. So it's more natural to get a decimal approximation here. All right, and if you do that, just go to your calculator and figure out what this is about. That's about 16.4. Okay, there's our average temperature. Okay, so we're done with the problem, but I would like to sneak a peek back at the graph of our temperature function, just see if we think that this answer is reasonable. Okay, so here's our temperature function again, and 16.4, that's maybe about here. What do you think? Does that look like a reasonable average temperature for this 3-hour period? Would you believe that? Okay, I would say that it at least looks reasonable because our function, notice that it's above, it's positive for a lot of the 3 hours. So it kind of makes sense that our average temperature should be greater than 0 degrees Fahrenheit. That's just a little visual confirmation of our answer.